Good morning, students. लास्ट लेक्चर में हम लोगों ने डिस्कस किया था हार्टनेल गवर्नर के बारे में कि व्हाट इज हार्टनेल गवर्नर एंड हाउ द हार्टनेल गवर्नर्स आर वर्क्ड. ओके, नेक्स्ट टाइप का स्प्रिंग कंट्रोल जो गवर्नर है वो बेसिकली है हमारा हार्टंग गवर्नर. हार्टंग गवर्नर इज ए स्प्रिंग कंट्रोल्ड गवर्नर. In this type of governor, the vertical arms of the bell crank levers are fitted with spring balls which compress against the frame of the governor. When the rollers at the horizontal arm press against the sleeve, in that case, when the rollers of the horizontal arm press against the sleeve, in that case, sleeve goes in downward direction. इस डायग्राम में आप समझ सकते हैं यहाँ पर हार्टंग गवर्नर का एक लेआउट है. इस गवर्नर में ये सेंटर लाइन जो है ये हो गया आपका स्पिंडल एक्सिस, स्पिंडल. ये स्लीव है आपका और स्लीव में रोलर अटैच्ड है. यहाँ बेल क्रैंक लीवर के वर्टिकल आर्म्स में स्प्रिंग हॉरिजॉन्टली अटैच्ड है और ये फ्रेम के साथ फिटेड है. ठीक है, कंप्रेस्ड फॉर्म में. जब भी आपका ये गवर्नर का स्पिंडल आपका रोटेट होगा, इस रोटेशन की वजह से बॉल्स बाहर की तरफ मूव करेंगे और जो आपका बेल क्रैंक लीवर का हॉरिजॉन्टल आर्म है वो अपवर्ड डायरेक्शन में स्लीव को एक पॉइंट पर होल्ड करेगा इक्विलिब्रियम कंडीशन में. ओके, तो हमने देखा था हार्टनेल गवर्नर में जो स्प्रिंग जो आपका रहता है कंप्रेस स्प्रिंग, वो फ्रेम से अटैच होके कुछ इस तरह से जो बेल क्रैंक लीवर्स होते हैं हमारे और स्लीव को डायरेक्टली फोर्स करता है. वो यहाँ पर फ्लाई बॉल्स होते हैं, बट यहाँ पर जो स्प्रिंग्स हैं वो आपकी हॉरिजॉन्टल है और बेल क्रैंक लीवर को फ्रेम है बेल क्रैंक लीवर के साथ अटैच है, वो स्प्रिंग कंप्रेस कर रहा है उसके वर्टिकल आर्म्स को यहाँ पर. ओके, नेक्स्ट टाइप का जो आपका स्प्रिंग कंट्रोल गवर्नर है वो विल्सन हार्टनेल गवर्नर है. A Wilson Hartnell governor is a governor in which the balls are connected by a spring in tension. यहाँ पर आप देख सकते हैं डायग्राम में बेल क्रैंक लीवर एक फ्रेम के साथ पिवटेड है. यहाँ पर वर्टिकल आर्म्स के को जो बॉल्स हैं उसको सेंटर पॉइंट को स्प्रिंग के साथ कंट्रोल अटैच कर दिया गया है. ओके, balls are connected by a spring in tension. An auxiliary spring is attached to the sleeve mechanism through a lever by means of which the equilibrium speed for a given radius may be adjusted. The main spring may be considered of two equal parts, each belonging to both the balls. तो इन विल्सन हार्टनेल गवर्नर एक की जो आप डायग्राम की हम बात करें, यहाँ पर बेल क्रैंक लीवर में जो बॉल्स हैं फ्लाई बॉल्स को स्प्रिंग के थ्रू यहाँ पर कनेक्ट किया जाता है और स्पिंडल में स्लीव अटैच है, हॉरिजॉन्टल आर्म स्लीव के साथ अटैच रहते हैं. यहाँ पर एक ऑक्सिलरी स्प्रिंग होती है जो एक लीवर के साथ कनेक्टेड होती है स्लीव के मूवमेंट को होल्ड करने के लिए. जब सेंट्रीफ्यूगल फोर्स जब स्पीड इंक्रीज होती है तो सेंट्रीफ्यूगल फोर्स बॉल्स का इंक्रीज हो जाता है और ये यहाँ पर वर्टिकल आर्म्स आउटसाइड डायरेक्शन में मूव करते हैं, जिसकी वजह से जो हॉरिजॉन्टल आर्म्स हैं बेल क्रैंक लीवर के वो अपवर्ड डायरेक्शन में मूव करेंगे और स्लीव का मूवमेंट अपवर्ड डायरेक्शन होगा. Whenever the speed of the governor is decreased, in that case the motion of the sleeve will be in downward direction. Now, the next type of spring control governor is Pickering governor. A Pickering governor is mostly used for driving gramophone. It consists of three straight leaf springs arranged at equal angular intervals around the spindle. Each spring carries a weight at the center. The weight moves outwards and the spring bend as they rotate about the spindle axis with increasing speed. तो यहाँ पर पिकरिंग गवर्नर में थ्री आर्म्स होते हैं, थ्री स्लीव्स स्प्रिंग्स होते हैं जो जिसमें आपका मासेस अटैच होते हैं और स्पिंडल में अटैच होते हैं। जब भी स्पीड इंक्रीज होती है सेंट्रीफ्यूगल फोर्स इंक्रीज होगा और ये जो स्प्रिंग्स हैं स्लीव स्प्रिंग्स हैं ये बैंड हो जाते हैं जिसकी वजह से स्लीव डाउनवर्ड और अपवर्ड डायरेक्शन में मूवमेंट करते हैं। ओके, तो ये कुछ टाइप के गवर्नर्स थे स्प्रिंग कंट्रोल गवर्नर, हार्टनल गवर्नर, हार्टंग गवर्नर, विल्सन हार्टनल गवर्नर एंड पिकरिंग गवर्नर। Now come to the next topic, sensitiveness of governors. Sensitivity or sensitiveness of the governor. What is the meaning of the sensitivity of a governor? Consider two governors A and B running at the same speed. When this speed increases or decreases by a certain amount, the lift of the sleeve of governor A is greater than the lift of the sleeve of governor B. It is then said that governor A is more sensitive than the governor B. Okay, what is the sensitivity of the governor? Sensitivity of the governor is the measure uh, by which we can say that the output or the movement of the sleeve by changing the load or the speed of the engine or the governor, okay, is more than other, yeah, or same governor. In general, the greater the lift of the sleeve corresponding to a given frictional change in speed, the greater is the sensitiveness. So जनरली गिवन स्पीड चेंज के लिए अगर जो लिफ्ट है स्लीव का या मूवमेंट है जो स्लीव का वो ज़्यादा हो, ओके, इन कंपैरिजन टू अदर गवर्नर, इन दैट केस दैट गवर्नर इज defined as the more sensitive governor. Okay, it may also be stated in another way that for a given lift of the sleeve the sensitiveness of the governor increases as the speed range decreases. So sensitiveness of the governor is a measure by which we can say that the given change for speed, how much movement of the sleeve will occur. Okay, more sensitive governor, the sleeve of the most sensitive governor is move rapidly or moves, the displacement of the sleeve is more than the other governors. This definition of sensitiveness may be quite satisfactory when the governor is considered as an independent mechanism. Okay, but when the governor is fitted to an engine, the practical requirement is simply that the change of equilibrium speed from the full load to the no load position of the sleeve should be as small as a fraction as possible of the mean equilibrium speed. तो ये रिक्वायरमेंट है एंड एक्चुअल जब वर्किंग कंडीशंस में गवर्नर्स यूज किए थे व्हेनेवर द गवर्नर्स आर यूज्ड फॉर एन इंजन इन दैट केस द sensitiveness of the governor is not more than uh, if the governor is more sensitive in that case whenever the speed changes due to the variation of the load. In that case, the sleeve of the governor will move rapidly in upward and downward direction or downward direction. So, in that cases, the in actual, we cannot control the speed of an engine on a constant speed. Okay, for maintaining a constant speed, it is required that the movement of the sleeve is very minimum. So, the fuel supply of the engine can be maintained at fixed amount or as per the load conditions. Okay, the actual displacement of the sleeve is immaterial material provided that it is sufficient to change the energy supplied to the engine by the required amount. For this reason, the sensitiveness is defined as the ratio of the difference between the maximum and minimum equilibrium speed to the mean equilibrium speed. Uh, the sensitiveness is the ratio of difference between the maximum and minimum equilibrium speed to the mean equilibrium speed. According to the definition of sensitiveness of the governor, we can say N1 if N1 is the minimum equilibrium speed and N2 is the maximum equilibrium speed. In that case, the mean equilibrium speed will be equal to the N1 plus N2 by 2, and the sensitiveness of the governor will be equal to the N2 minus N1 upon n, as per the definition of the governor, that the range of speed divided by the mean speed is the sensitiveness of the governor. So, we know that the uh, mean equilibrium speed will be equal to the n1 plus n2 by 2. So, according to the definition, sensitiveness of the governor will be equal to the 2 bracket n2 minus n1 upon n1 plus n2, or in the case of angular speeds, it is equal to the 2 into omega 2 minus omega 1 upon omega 1 plus omega 2. So, it is desirable that the sensitiveness of the governor is not uh, greater. Now, the second topic is the stability of the governors. What is stability of the governor? A governor is said to be stable when for every speed within the working range there is a definite configuration, that is, there is only one radius of rotation of the governor. Balls at which the governors is in equilibrium. For a stable governor, if the equilibrium speed increases, the radius of the governor balls must also increase. So, what is the stability of the governor? A governor is said to be stable when for every speed within the working range there is a definite configuration. So, a governor is said to be stable when the governor's sleeve attends a fixed position according to the fixed position respected to the uh, speed of a governor. Okay, so the governor is known as stable governor. Isochronous governors. A governor is said to be isochronous when the equilibrium speed is constant for all radius of rotation of the balls within the working range, neglecting friction. The isochronism is the stage of infinite sensitivity. So, a governor is to be isochronous when equilibrium speed is constant. So, for a uh, Porter governor, Proyal governor, and Hartnell governor, for the centrifugal type governor, it is impossible to have a isochronous governor, because for a different equilibrium speed the position of the sleeve will be different. Okay, so the equilibrium speed cannot be constant for the centrifugal type governors or deadweight type governors, but in the case of a spring control governor, the equilibrium speed can be fixed due to the variation of the spring force. Okay, so Porter, Proyal, and Watt governor cannot be a never be a isochronous governor. Isochronism only can can seen in the spring control governors. Okay, like Hartnell governor, Wilson Hartnell governor, Pickering governor, or Hartung governors. Now the next topic is hunting. It is very important topic. It is a very important topic. Hunting. What is hunting? A governor is said to be hunt if the speed of the engine fluctuates continuously above and below the mean speed. This is caused by too sensitive governor which changes the fuel supply by a large amount when a small change in the speed of the rotation takes place. As I already told you that if the sensitivity of the governor is more, in that case whenever a change in the load, if the governor sensitivity is more, in that case the sleeve of the governor will move respectively more than the less sensitive governor. In that case, the fuel supply will increase suddenly in the engine, due to which the speed of the engine will changes rapidly, and due to this rapid changes and more sensitive governor, the sleeve of the governor will move rapidly between above and below of the equilibrium speed. So this phenomena, the movement of the sleeve below and above of the equilibrium speed, is known as the hunting. Okay, and hunting occurs whenever the governor is the more sensitive governor, or the sensitivity of governor is more. Okay, so to avoid the hunting process uh, in the governors, we used Hartnell governors or spring control governors. Hello. So, for example, when the load on the engine increases, the engine speed decreases. And if the governor is very sensitive, in that case, the governor sleeve immediately falls to its Fuel supply to the engine, and thus the engine speed begins to fall once again. This cycle is repeated indefinitely. This process is known as hunting of the governor. Gears are used for transmit the power. Okay, for transmitting the power, we will use chain, belts, and other systems. But the efficiency of these systems is not 100%. But the efficiency of transmission of in the transmission of the power in the case of a governors, sorry, in the case of the gears is 100% because there is no slip between the. Efficiency of the governor is high. It has reliable service. Gears are compact in layout. The layout of the gear are very compact in comparison to belt and chain drives. The gears are manufactured by special tools and equipments. The error in cutting teeth may cause vibration and noise during operations. The main disadvantages of the gears are uh, gears manufacturing So gears can be classified by according to the four types. First, according to the position of axis of the shaft, parallel shaft, intersecting shafts, non-intersecting and non-parallel. According to the position of the axis of the shafts, gears may be classified as parallel, intersecting, and third non-intersecting. Axis of the wheel. These gears have parallel to the axis of the wheel. Another name given to the spur gear is helical gearing, in which the teeth are inclined to the axis. The single and double helical gear connecting parallel shafts, as shown in respectively in figures. The double helical gears are known as next. The two non-parallel or intersecting but coplanar shaft connected by gears as shown in figure. The bevel gears, like spur gears, may also have their teeth inclined to the face of the bevel, in which case they are known as helical bevel gears. The two non-intersecting and non-parallel, that is non-coplanar shaft connected by gears is shown in figure 4. These gears The gears, according to the peripheral velocity of the gears, may be classified as low velocity, medium velocity, and high velocity. The gears having velocity less than 3 meter per second are termed as low velocity gears, and gears okay. So what is external gearing? In the diagram A, first diagram, the gears, the teeth of on the gears are pinion gearing. In the rack and pinion gearing, uh, we have a straight bar having a teeth and a pinion which have pinion have a teeth on a disc or is in circular uh, position. Okay, teeth are cut on a circular position, but in the case of a rack, teeth are cut. वो आपके तीन तरह से हो सकते हैं, स्ट्रेट कट किए जा सकते हैं, इंक्लाइंड कट किए जा सकते हैं और कर्व्ड बनाए जा सकते हैं। तो पोजीशन ऑफ द टीथ के अकॉर्डिंग हम उसको क्लासिफाई कर सकते हैं। Some terms used in gears. मूव जो एंटर करते हैं वो क्लियरेंस और वर्किंग डेप्थ सर्किल तक ही केवल एंटर करते हैं, उसके टीथ का अपर फेस, ठीक है। इसके नीचे वो मूव नहीं करते। इस पूरे इसके बीच की डिस्टेंस को, रेडियल डिस्टेंस को क्लियरेंस कहा जाता है, ये क्लियरेंस, ठीक है। क्लियरेंस सर्किल के ऊपर होता है हमारा पिच सर्किल। दोनों जो गियर्स जिनमें गियरिंग हो रही है, यानी ये हमारा डिडेंडम है। और पिच सर्किल से एडेंडम तक की रेडियल डिस्टेंस को कहते हैं एडेंडम, डिडेंडम एंड एडेंडम। पिच सर्किल पर जो टीथ में जो लाइन होती है, ठीक है, हॉरिजॉन्टल लाइन, उसे हम कहते हैं पिच सरफेस एलिमेंट, ओके। एडेंडम से डिडेंडम तक की टोटल डिस्टेंस को हम कहते हैं वर्किंग डेप्थ। एडजेसेंट टीथ्स की सर्कमफ्रेंशियल डिस्टेंस को सर्कुलर पिच कहा जाता है। ये कुछ चीजें हैं जो हमें पता होनी चाहिए। So, terms used in gears. First is pitch circle. What is pitch circle? It is an imaginary circle Now, pitch point. It is the common point of contact between two pitch circles are known as pitch point. Okay, pitch surface. It is the surface of the rolling discs when the meshing gears have replaced at pitch circle. So pitch circle diameter, pitch point, and pitch surface. $20 होता है. Now, addendum. What is the addendum? It is the radial distance of tooth from the pitch circle to the top of the tooth is known as addendum. Dedendum. It is the radial distance of a tooth from the pitch circle to the bottom of the tooth is known as dedendum. Addendum circle. Okay. Now, dedendum circle. It is a circle drawn through the bottom of the teeth and concentric with the pitch circle is known as dedendum circle. Is It is also called root circle. So, Diameter of the pitch circle, and T is the number of teeth on the wheel. A little consideration will show that the two gears will mesh together correctly if the two wheels have the same circular pitch. If the circular pitch is not equal, in that case the gears will not mesh. To the number of teeth is known as module. It is usually denoted by small m, and according to the definition of module, so module will be is equal to the diameter of diameter of pitch circle divided by number of teeth. This is the module. Okay. Now depth, it is the radial distance from the addendum circle to the clearance circle is known as working depth. It is equal to the sum of the addendum of the two meshing gears. Tooth thickness, it is the width of the tooth measured along the pitch circle is known as tooth thickness. It is the surface of the top of the tooth is known as top land. Face width, it is the width of the gear tooth measured parallel to its axis. Profile, it is a curved formed by the face and flank of the tooth is known as profile. Fillet, radius. It is the radius that connects the root circle to the profile of the gear bottom.